Hi class. One of the concepts that we're going to use regularly throughout the semester is the concept of a watershed. And a watershed by definition is the area of land over which all of that precipitation that falls on that land drains to a single point. And interesting definition by John Wesley Powell here: the area of land, a bounded hydrologic system within which all living things are inextricably linked by their common watercourse, and whereas humans settled, simple logic demanded that they become part of a community. I think that's kind of a cool definition. But a little more scientifically, what we're talking about is outlined on this diagram here: the land area over which all the precipitation that falls on this land is going to drain to this single point here. So a watershed, some synonyms for watershed is river basin, catchment, watershed. You can have a sub-watershed, a drainage basin, drainage area. So it's the delineating the area that contributes runoff to a single outlet. And the water gets to that outlet by means of a network of drainage pathways, which may be on the surface or may be underground. So water can migrate to an outlet via subsurface pathways. And those pathways converge into a stream or river system that gets bigger and bigger as the water moves downstream. So every stream, every tributary, every river has an associated watershed. So the Colorado Foundation for Water Education did a survey a few years ago asking Coloradans if they lived in a watershed, and it was remarkable. More than half of the people said no, they didn't. So it's impossible to live on the continental land surface anywhere on the planet and not be in some watershed. You are in a watershed for some drainage somehow. You can define watersheds that are small or watersheds that are large. Small watersheds aggregate to become larger ones. So for example, we could look at, here's the watershed of the Missouri River, which is part of the Grand Mississippi River drainage area, and so is the Ohio, and the Arkansas Red-White, the Tennessee. So we have all these smaller watersheds that combined together to comprise the entire watershed or drainage area of the whole Mississippi River. We could look at smaller watersheds like the watersheds in the Colorado National Monument. And one of these, Gold Star Canyon, is one that you'll be delineating in your homework. So these, and you can define any outlet. So I, somewhat arbitrarily, but it was because I was doing a study for the National Monument, defined the outlet of these watersheds as the park boundary. So when the water left the national park. And then we looked at what's the watershed area above the point where the water leaves the national park. You could take these drainages all the way down to the Colorado River and delineate the watershed above the Colorado River. So we could be any size, or they could be large. And the line that divides one watershed from another is called a watershed divide, or an interfluve. That defines the boundary of our watershed, and it follows any major ridge line around the channel. So it follows all the high points, and it meets at the bottom where the water flows out of the watershed. So if you start drawing your watershed boundary at the bottom, you're going to be going uphill and around the watershed. So all the flow within the boundary is going to drain to that outlet, and flow outside of the boundary is going to drain to the next drainage area. So another way to test whether certain land area is in your watershed or in the adjacent watershed, because one of the things you're going to do is be drawing this boundary, this divide, to delineate a watershed. So let's say you've got a spot and you're not sure, is that in my watershed that I'm delineating, or is it in the next one? You can imagine that you're a drop of water and you follow how that drop of water flows down the hill. And if it flows into a tributary to your drainage, then it's in that watershed. And if it flows in the other direction, you know it's not. Surface water can't flow across a watershed boundary. So surface water can't flow across a watershed divide. So we've been looking at water balance equations in the hydrologic cycle. Here's our little schematic of a watershed with all the hydrologic processes occurring. Usually you're not going to have groundwater flow in. It depends, but that's commonly you're not going to have groundwater flow in. So you've got your precipitation on your watershed, evapotranspiration, and runoff. Okay, so why do we care about watersheds so much? really interesting looking back, through American history. John Wesley Powell, when he explored the West, and John Wesley Powell was a brilliant observational scientist, and he spent a lot of time wandering around the arid West, and he came up with a proposal for what our states should look like. And he thought that the states should follow watershed boundaries rather than these straight line boundaries. And he really believed in this idea of having these watershed communities. He called them watershed commonwealths. And he had some real different ideas about how much land should be used for agriculture and homesteading, but he was a little too late because development of the West had already begun, and the senators from the western states didn't want to slow the development of the West, and so it continued to move forward. So this is a modern drawing of what would the United States look like if we followed watershed boundaries rather than our square state boundaries, which it really gets interesting to think of how different politically things might be if our states were watersheds and not straight line states. So precipitation in the watershed results in the stream flow at the outlet. And one of the main things we're going to be looking at through the semester is working our way through these different hydrologic processes to get to the point where we can model stream flow. The characteristics of the watershed affect the stream flow. So is your watershed vegetated? Do you have deep soils, or do you have shallow soils? Is it paved? Is it steep? Is it flat? All of those characteristics in your watershed are going to control the pathways and the rates with which the water moves through the stream network, moves to the stream network, and then moves through the stream network. So the geology of the watershed, the topography, the land cover, all of those things are going to affect the quality of the groundwater and surface water and the magnitude and timing of the stream flow and the groundwater outflow. So in land use planning and thinking about water supply planning, water resource planning, thinking about flooding, everybody recognizes that effective management of water quality and quantity requires a watershed perspective. And what's really interesting is we're starting to see more and more watershed groups developing that are starting to take that perspective. Unfortunately, political boundaries don't generally follow watershed boundaries. In fact, often political boundaries follow rivers, which would, those are not watershed divides. So when you are delineating a watershed, where do you start? The best thing to do is to identify your outlet. So on your homework, your outlet is going to be where Gold Star Canyon, the stream that drains Gold Star Canyon, crosses the national park boundary. So that stream cross section is going to define the outlet of your watershed. And the location of where you're going to choose your outlet depends on the purpose of your study. So for our study, we're going to say we're looking at the stream flow that flows out of the national monument. So often you might pick a stream gauging station and then delineate the watershed upstream. There are an infinite number of points you could pick along any given stream to then draw an infinite number of watersheds. Okay, so you start at your stream outlet, and that's going to be the lowest point in your watershed. That's the lowest elevation in your watershed, so we'll be going up from there. And one of the things that I think is really helpful is if you go through and you highlight all of the blue lines on your map, and the dash, those include solid blue lines and dash dot blue lines. So those are our intermittent streams that don't always have water in them, but take a highlighter and use a highlighter because then you can still see the contour lines and what's going on behind, and highlight the stream network. And even for the streams that are not in your watershed, because once you've highlighted that stream network, then you can start to actually just see the rough outline of your watershed, because you can tell where the headwaters are, and you know if you've got two sets of headwaters like this, then you know the watershed divide's got to go between them. So it's really helpful to highlight that stream network first and use an actual highlighter to do it, because if you use a dark pen, it kind of it just doesn't work as well. All right, so highlight your stream network. The other thing you want to be thinking about is where do you have swales or little gullies that are channeling the water down towards your main stem of your stream. And you know that the topography is forming a little rill or channel or gully if the topo lines make a V, and if the point of the V points uphill. So, so the V-shaped contours are pointing in the opposite direction of stream flow. So we know stream flow has to go from high elevation to low elevation. So if the V is pointing uphill, then it's the V, the point of the V, is pointing in the opposite direction of the stream flow. So it's really helpful to sort of not only just identify the blue line stream network, but start to look at where you start to see gullies that are flowing into the blue lines. Let me go back up here. So you can see this is a hilltop, so a closed polygon. If it doesn't have little Hetcher marks, you know, is a high point. If it has Hetcher marks, it's a low point or depression. So here's a hilltop, so we know the water is going to be flowing off of that hilltop. And all these little crenulations, kinks in our contour lines are little gullies. And so you could actually say, oh, here's a little drainage right there, and here's another little drainage there, here's another one there, and over here this is probably in a different watershed flowing in a different direction. So our watershed divide would follow the top of this hill and then come down this ridge line. There we go. So that's where our watershed divide would actually go. Okay, so runoff has to flow perpendicular to contour lines. And so here's our stream here, and the runoff is flowing perpendicular to the contour lines down to the stream. All right, another thing that could be really helpful in delineating your watershed is to identify all the high elevation points in the area that you're mapping. And you can put a little X on them, and then eventually what you'll be able to do is basically connect the dots. So many of those points are actually going to be on your watershed boundary, and it might help you to visualize the features in 3D. So that's another helpful step. And so to think about what's going on with topography, so here we have the high point here, and this is going down. So we can see this V is pointing uphill. Stream flow would go down like this, and if we did a cross section across here from A to A prime, we go high, low, and then back up to high. So this is a cross section across a valley. And then here, notice we've got the point of our V is actually a lower elevation, so it's 100. And so the point is pointing to a low elevation, so that means what we've got is a ridge line. So if we take a cross section across it, we're going to go up, we get to the top, and we go down. All right, so closed polygon here is a hilltop. If we went from here, we'd be going up to the top of the ridge and down again the other side. So if we think about where a drop of water is going to flow off of this, it's going to flow at right angles to the contour lines off of the top of the hill. So you're going to identify your high points. These closed circles are hilltops, so go put an X on these different hilltops, and that can help you sort of see the outline of your watershed. And again, think about the fact that the water has to flow perpendicular to the contour line. So you can't go that way, and it can't go that way over here. All right. So then you can go in and start sketching your boundary or divide. And remember that divide, it's dividing the land that slopes to one outlet from the land that slopes to another outlet. And sketch, at this point, use pencil. For marking the X's for the high point and drawing your boundary, use a pencil. Things can get a little tricky in flat areas. Sometimes what I'll do is start going around my watershed one way. You might get kind of stuck, so then you go back to the outlet and start going around the other way, and eventually you can get your two sides to come together and meet. So this is talking about sketching it. So we start at the watershed outlet and start heading up around the sides. And then go and check where water is going to flow from your any of your high points. So here's a stream coming down like this. Here's our watershed outlet. And you can see the divide goes up, crossing contour lines perpendicularly, crossing the high points, the tops of the hills. And sometimes it does some funny things, but you've got to catch those high points. Up this ridge. Notice there's some little crinkles in the contours here, but that's going to flow that way. And these little crinkles cause the water to flow that way. Up to this high point and then around to here. And here's another one, for example. So, so the dark solid line is the stream network. So we start at the outlet and we start heading up, crossing contour lines perpendicular. This is a ridge, so it makes like a V, but the V points downhill, more like a U. Up around the watershed, we cross the hill and then down the ridge on the other side. And then check your boundary. Pick some points and make sure the water flows to your stream and flowing down at right angles across the cross section. All right, the lowest point in the drainage basin is always at your outlet. The divide never crosses a stream, and the divide is always at right angles to the contour lines. So those are some rules you need to make sure you check that you follow. That's it. Send me an email if you have questions about your watershed delineation.